Do you know that right now, as you're watching this video, we're hurtling through space at an incomprehensible speed of 2.2 million kilometers per hour? But here's the terrifying part, it's not just Earth that is moving. Our entire Milky Way galaxy, with its over 400 billion stars, is being dragged towards something so massive, so mysterious, that astronomers call it the Great Attractor. And the most unsettling discovery is that we can't even see what's pulling us. For decades, scientists have known that our galaxy isn't just drifting aimlessly through space. Something with the gravitational pull of tens of thousands of galaxies is pulling us toward a region of space that lies hidden behind the dust clouds and stars of our own Milky Way. Today, we're going to uncover one of the universe's most fascinating mysteries of the universe. What is the Great Attractor, and what does it mean for the future of our galaxy? Welcome to our channel, Secrets of the Sky, where we explore the universe's most incredible mysteries. If you're fascinated by the cosmic forces that shape our reality, make sure to subscribe and hit that notification bell. Because what we're about to discover will change how you think about our place in the universe forever. Let's start with a discovery that turned our understanding of cosmic motion upside down. In the 1970s, astronomers thought they had figured out how galaxies move through space. According to the prevailing theories, galaxies should be moving away from each other due to the expansion of the universe, a concept known as Hubble's law. But when scientists began measuring the motion of our local group, that's the cluster of galaxies that includes the Milky Way, Andromeda, and about 80 smaller galaxies, they found something that shouldn't exist. We weren't just expanding away from other galaxies. We were moving in a specific direction through space at an incredible speed. This movement couldn't be explained by the Big Bang's expansion alone. In 1976, a team of astronomers, George Smoot and his team, were studying the cosmic microwave background radiation, essentially the afterglow of the Big Bang, when they noticed something spectacular. The radiation wasn't perfectly uniform. There was a slight temperature difference between one side of the sky and the other. This temperature difference revealed that our entire local group of galaxies was moving at 627 kilometers per second. That's over 2.2 million kilometers per hour towards not just the constellation Hydra. But moving toward what? The answer would take another decade to uncover, and when it did, it revealed one of the most massive structures in the known universe. In 1986, a team of astronomers led by Alan Dressler, Sandra Faber, and others published a groundbreaking study. They had been measuring the velocities of galaxies in our local region of space, and what they found was unprecedented. Not just our local group, but thousands of galaxies across hundreds of millions of light years were all flowing in the same direction. They were moving toward a region of space located about 250 million light years away, in the direction of the constellations Hydra and Centaurus. The gravitational influence causing this cosmic migration was so powerful that it had to contain the mass equivalent of tens of thousands of galaxies. They called it the Great Attractor. Here's where this mystery becomes even more fascinating. The Great Attractor lies in what astronomers call the Zone of Avoidance. A region of space that's completely hidden from our view by the dust, gas, and stars of our own Milky Way galaxy. Imagine trying to access something incredibly important, but it's located directly behind a massive wall that you can't see through. That's exactly the predicament astronomers found themselves in. They could detect the Great Attractor's gravitational effects. They could see thousands of galaxies being pulled toward it. But they couldn't see the attractor itself. For years, scientists could only estimate what might be lurking in that hidden region of space. Early calculations suggested that the Great Attractor would need to have the mass of approximately 50,000 galaxies like our Milky Way to exert such a powerful gravitational influence across such vast distances. But as technology advanced and new observation techniques became available, astronomers began to piece together clues of what might be hiding behind our galactic dust. Using radio telescopes, which have the capability to penetrate through the obscuring material of the Milky Way, scientists started mapping the distribution of hydrogen gas in the zone of avoidance. What they found was extraordinary. There were indeed massive galaxy clusters lurking behind the cosmic curtain. In the 1990s, infrared telescopes provided even clearer pictures. Infrared light can pass through dust that blocks visible light, allowing astronomers to peer deeper into the zone of avoidance than ever before. These observations revealed not just one massive structure but an entire complex of galaxy clusters. The most significant discovery came with the identification of the Norma cluster and the Centaurus supercluster, a massive collection of galaxies hidden behind the Milky Way. But even these enormous structures couldn't fully account for the gravitational pull that was affecting such a vast region of space. Then came a discovery that would revolutionize our understanding of cosmic structure. The Great Attractor, it turned out, wasn't the end of the story. It was just one part of something much, much larger. In the late 1980s and early 1990s, astronomers began to realize that the Great Attractor itself was being influenced by an even more massive structure. About 650 million light-years away, in the direction of the constellation Centaurus, lies one of the most massive known superstructures in the observable universe, the Shapley Supercluster. Named after the American astronomer Harlow Shapley, this cosmic monster contains more than 8,000 galaxies and has a total mass estimated at 10 million billion times the mass of our Sun. To put that in perspective, that's equivalent to about 10,000 galaxies the size of the Milky Way. The Shapley Supercluster is so massive that its gravitational influence extends across more than 1 billion light-years of space. It's not just pulling our local group in the Great Attractor, it's influencing the motion of thousands of galaxy clusters across a significant portion of the observable universe. But here's what makes this discovery even more incredible. The Shapley Supercluster represents what astronomers call the Great Attractor's Great Attractor. It's the ultimate source of the gravitational pull that's been dragging our galaxy and millions of others across cosmic distances for billions of years. Let me explain how this cosmic hierarchy works. Imagine a river system. You have small streams that feed into larger rivers, which then flow into even larger rivers, until everything eventually reaches the ocean. The universe's structure works similarly. Our local group is like a small stream, being pulled toward the Great Attractor, which is like a major river. But the Great Attractor itself is flowing toward the Shapley Supercluster, the cosmic ocean that dominates gravitational flow across our region of the universe. What's remarkable is that this cosmic flow has been happening for billions of years. Long before Earth formed, long before our solar system existed, our galaxy was already on this journey toward the Shapley Supercluster. And it will continue long after our Sun dies and humanity is gone. But the story doesn't end with the Shapley Supercluster. Recent discoveries have revealed that our cosmic neighborhood is even more complex and dynamic than anyone had imagined. To truly understand the Great Attractor and the forces pulling our galaxy through space, we need to zoom out and see the biggest picture possible, the structure of the universe itself. Modern astronomy has revealed that the universe is organized like a vast cosmic web. Galaxies aren't randomly scattered through space. Instead, they're arranged in an intricate network of filaments, walls, and voids that stretch across billions of light years. Picture a spider's web, but instead of silk strands, imagine threads made of galaxies, galaxy clusters, and dark matter stretching across unimaginable distances. Where these cosmic filaments intersect, you find the most massive structures in the universe's superclusters like Shapley. Our Milky Way galaxy sits on one of these cosmic filaments, and like a bead on a wire, we're sliding along this structure toward the densest, most massive intersection point in our local region of the universe. This cosmic web structure formed in the early universe, shaped by the gravitational influence of dark matter, the mysterious substance that makes up about 27% of the universe but doesn't interact with light. Dark matter created the scaffolding upon which normal matter, the stuff that makes up stars, planets, and us could accumulate. The Great Attractor and the Shapley Supercluster represent dense nodes in this cosmic web where enormous amounts of both dark matter and normal matter have accumulated over billions of years. Their massive gravitational fields create what astronomers call attractors, regions that pull surrounding matter toward them. But here's the most dramatic part of this story. Recent research has shown that our local group isn't just moving toward the Shapley Supercluster. We're actually moving away from something as well as a vast cosmic void called the local void. Cosmic voids are enormous regions of space that contain very few galaxies. They're like cosmic deserts in the web of matter. The local void, which lies in the opposite direction from the Great Attractor, contains almost no matter. Its lack of gravitational pull effectively pushes matter away, while the dense regions like Shapley pull matter toward them. So our galaxy is caught up in a cosmic tug-of-war. Being pushed by the empty local void behind us and pulled by the massive Shapley supercluster ahead of us. This push-pull dynamic explains why our motion through space is so rapid and so directed. Understanding this cosmic flow raises fascinating questions about the future of our galaxy and the ultimate fate of our local region of the universe. So what does this cosmic journey mean for the future of our galaxy, our solar system, and ultimately, for us? First, let's address the timeline. Our galaxy is moving toward the Great Attractor region at about 627 kilometers per second, which sounds incredibly fast. But space is so vast that this journey will take an almost incomprehensible amount of time. The Great Attractor is about 250 million light-years away. At our current speed, it would take approximately 10 billion years to reach it. To put that in perspective, our Sun is only 4.6 billion years old, and it has about 5 billion years of fuel left before it begins dying. So this cosmic migration won't affect life on Earth or even our solar system for billions of generations. Long before we reach our destination, our Sun will have evolved into a red giant and eventually a white dwarf. Earth itself will be uninhabitable due to stellar evolution long before cosmic motion becomes relevant to human survival. But the implications for our galaxy are profound. As we approach the Great Attractor region, we'll encounter denser concentrations of galaxies. This could lead to more galactic interactions, possibly even galactic collisions and mergers. In fact, we already know that our Milky Way is on a collision course with the Andromeda Galaxy in about 4.5 billion years. This collision is separate from our motion toward the Great Attractor, but it shows that galactic interactions are a normal part of cosmic evolution. When galaxies collide, they don't crash like cars in an accident. Instead, they engage in a slow motion of gravitational dance that can last hundreds of millions of years. Stars rarely collide because space within galaxies is mostly empty, but the gravitational interactions reshape both galaxies dramatically. Our journey toward the Shapley Supercluster is part of a larger cosmic evolution. Over billions of years, the expansion of the universe will eventually overcome the gravitational attraction between distant structures. But locally, gravity will continue to pull matter together into larger and larger structures. Eventually, in the far distant future, trillions of years from now, our local region of the universe may become part of a single, enormous galactic structure as all the galaxies in our cosmic neighborhood merge together. This future galaxy would be unimaginably large and would contain the combined stellar populations of thousands of today's galaxies. There's something both humbling and inspiring about understanding our place in this cosmic flow. We're not just passengers on a planet orbiting a star. We're part of a vast, dynamic universe where everything is connected through gravity and motion on scales that dwarf human imagination. The Great Attractor represents one of astronomy's most fascinating mysteries, a cosmic force so powerful it's pulling our entire galaxy through space, yet so hidden we can barely study it directly. From its discovery in the 1980s to our modern understanding of cosmic structure, This invisible giant has taught us that our universe is far more dynamic and interconnected than we ever imagined. We've learned that our galaxy isn't just drifting through space, it's part of a vast cosmic flow that includes thousands of other galaxies, all moving together toward the most massive structures in our region of the universe. We've discovered that what we initially thought was the Great Attractor is actually part of an even larger structure, the Shapley Supercluster that dominates the gravitational landscape across billions of light years. Most remarkably, we've learned that this cosmic journey has been happening for billions of years and will continue for billions more. We're passengers on a galactic voyage that began long before Earth existed and will continue long after our sun dies. The next time you look up at the night sky, remember that you're not just looking at static points of light. You're seeing a universe in motion. Galaxies, stars, and planets all participating in a cosmic dance choreographed by gravity and played out across distances and timescales that challenge human comprehension. If this journey through cosmic space has amazed you, make sure to subscribe to Secrets of the Sky for more fascinating explorations of our universe. Hit that notification bell so you never miss our latest discoveries about the cosmos. What aspect of the Great Attractor fascinates you most? Are you more intrigued by the mystery of what we can't see or by the incredible scales of motion and time involved? Let me know in the comments below. And if you want to explore more cosmic mysteries, check out our playlist on dark matter and the structure of the universe. The link is in the description. Until next time, keep looking up. And remember, we're all traveling through space together on the most incredible journey in the universe.